everyone. So today we're still discussing Module 2 information, atoms, elements, and matter. Last time we started Chapter 3 and we talked about how to classify matter into pure substances or mixtures. And today we're going to talk about states of matter and their properties. All right, so we're going to start with solids. So a solid is a state of matter, and then we'll talk about liquids and gases. So solids have a definite shape. So looking at the crystal or the amethyst off to the right, we can see that there's a definite shape there, and it's going to maintain that shape unless we manipulate it. So solids have a definite shape. They also have a definite volume. So we could measure the volume of that amethyst by maybe volume displacement. So maybe if we dunked it in some water and then tracked the change in volume, we could figure out the volume that way. And then solids also have particles that are close together in a fixed arrangement. So if we zoom in on that amethyst, we would see that there are particles that are really close together and they're kind of stuck in that position. So they're very rigid. And in particular, we have two elements here, silicon and oxygen. And so oxygen is shown in red, silicon is shown in gray. And again, you'll notice that they have a very particular arrangement there. Now, because solids are very fixed and rigid, the particles in a solid move very slowly. So they might be able to vibrate a little bit in their particular position, but they're not moving around. They're just stuck where they are. Now, liquids have an indefinite shape, but they have a definite volume. So liquids are a little bit different from solids in that sense. So off to the right, we have water in several different types of glassware. So we have a wine glass, a champagne flute, and then a regular glass in the back. So all of these different glasses have the same volume of water, but you'll notice that the shapes are very different. So water, which is a liquid, takes on the shape of the container that it's in, which is what indefinite shape means. So takes on the shape of its container. But you can still measure the volume of the water. Now, I guess the definition of indefinite shape is down below, the same shape as their container. Now, liquids are similar to solids in that the particles are still close together, but it's different because the particles can move around. So the particles that are close together but mobile. So for instance, if we're looking at these water molecules or these particles, they're all really close together in this glass, but they can move around each other. So maybe they're kind of doing a little dance around each other there. And so you can imagine, for instance, a river flowing. The particles can move, but they're still really close together as they're moving. Now, if water is just kind of sitting in a glass, like in this example, the particles also move fairly slowly. All right, and then gases is our last state of matter. Now, gases are pretty different from solids and liquids. They have an indefinite shape. So again, they take the same shape as their container, but they also have an indefinite volume. So that means that gases have the same shape and volume as their container. So you can imagine gases in a balloon. So maybe helium, for instance. And helium, we said, was an element. And all of the different particles of helium are going to fill that space in the balloon. So the particles are actually going to be far apart from each other. So again, gases are pretty different from solids and liquids. In solids and liquids, particles are close together, but in gases, they're really far apart. They also have a lot of energy, so particles in a gas move very fast. So you can see these particles are all zipping around in this balloon. So again, that makes them different from solids and liquids. Now, some of you might be wondering about plasma. So plasma's, in essence, an ionized gas. And some people do consider plasma another state of matter. But for this class, we're going to ignore plasma, and we're just going to consider solids, liquids, and gases. All right, so let's do a learning check. Let's identify each description below as that of a solid, liquid, or gas. So feel free to pause the video if you want to try this on your own first, and then we'll go over it together. Okay. So A, it has definite volume, but takes the shape of the container. Would that be a solid, a liquid, or a gas? A liquid. So remember, liquids, you can measure their volume, but they are going to take on the shape of the container that they're in. What about B? Its particles are moving rapidly. Does that describe a solid, a liquid, or a gas? A gas. So we just said that the particles in a gas are very energetic, so they move very quickly. What about C? Its particles fill the entire volume of a container. That is also a gas. So liquids can take on the shape of their container, but they're not necessarily going to fill the container. It depends on their volume. Whereas gases definitely fill the room that they're in or the container that they're in. What about D? Its particles have a fixed arrangement. Is that a solid, a liquid, or a gas? A solid. So remember, solids have particles that are really close together and in a fixed arrangement. Liquids also have particles that are close together, but they're not fixed. So liquid particles can move around each other. What about E? Its particles are close together, but moving randomly. A liquid. So we just said that, right? All right, great. And then here's the solution slide if you need that later. And let's do one more. Identify the state of matter for each of the following. So we're going to identify each of the following as a solid, a liquid, or a gas. So let's do this one together. So A, are vitamin tablets a solid, a liquid, or a gas? A solid. Unless you get the gummies like I do. They're a little tastier. B, what about eye drops? Are those solid, liquid, or gas? Liquid. And vegetable oil, is that a solid, a liquid, or a gas? A liquid. What about a candle? That's a solid, right? Until you melt it and then it becomes more liquidy. And then what about air in a tire? That is a gas. Okay. Here's the solution slide. So now that we know about solids, liquids, and gases, let's talk a little bit about their properties. And there are two different types of properties we can discuss. We can talk about physical properties as well as chemical properties. So let's talk about physical properties first. So physical properties are characteristics observed or measured without changing the identity of a substance. All right, so when I think about these properties, I kind of like to think about myself, which might sound narcissistic, but when I think about characteristics of myself that I can observe without chemically changing them, my hair color is brown and a little bit of gray. But I can't change that unless I dye my hair, which is a chemical process. So hair color, or natural hair color, is a physical property. Similarly, my eye color is blue, so that's a physical property. So we can also talk about chemicals in the same way. So we could observe a solid object, and whatever we observe about that object, like its color, its shape, its texture, those are all physical properties because we cannot change them. So again, physical properties include shape, physical state, so solid, liquid, or gas. Also, for chemicals, we can talk about the boiling and freezing points. So we can also talk about density. That's something that is very intrinsic to a material or a substance. And then also color. So for instance, let's say we're observing a glass of water, which sounds kind of boring, but bear with me here. So the shape of the water will just be whatever its container is. Its state is a liquid. Its boiling point is 100 degrees Celsius, and that's always true for water, at least at sea level. We'll talk more about that later. And then the freezing point of water is 0 degrees Celsius, and that never changes, with some exceptions. And then the density of water, we said in a previous lecture, was 1 gram per milliliter. And then the color. Water is generally colorless. All right, so these are all physical properties of water. So now let's look at another example. This time we'll look at copper. So copper is a reddish orange color. It's shiny. We can also consider its conductivity as a physical property. So copper does conduct heat and electricity really well. It's a solid at 25 degrees Celsius. Its melting point is really high, 1083 degrees Celsius. And its boiling point is also really high, 2567 degrees Celsius. So the melting point and boiling point of copper is really high, which is good for cooking. So copper is typically used in cookware, and you can see some pots and pans over there made of copper. But additionally, copper can conduct heat really well, so that's why we also use it in cookware. But again, these are some physical properties that describe copper. And again, we're not changing the identity of copper when we're describing these properties. Now we can also talk about physical changes that substances go through. So a physical change occurs if there is a change in the state. So let's say we have ice, which is made of water, and then we melt it, and we get liquid water. So that would be a change in state. So we're going from solid to liquid. So that would be a physical change. A physical change is also a change in the physical shape. So let's say we hammer a rock into pieces. Oh. So we're not changing the chemical composition of the rock, but we are changing its shape. It's going from a full rock to little pebbles. And then a physical change, again, does not involve a change in identity. So no change in the identity and composition of the substance. And that's a key point because we're about to talk about chemical properties and chemical changes, and that does involve a change in the identity of your substance. But first, let's do a learning check. So let's classify each of the following as a change of state or a change of shape. So we have change of state or change of shape. So let's do this one together. So A, if we're chopping a log into kindling wood, so we're chopping it into little pieces, is that a change of state or change of shape? Shape. What about if we boil water? Is that a change of shape or a change of state? So that's a change of state because the water is going from a liquid to a gas. And then what about ice cream melting? Is that change of state or shape? So that's a change of state. So it's going from something that's frozen to something that's more liquid. What about ice forming in a freezer? Change of state. So we're going from liquid to solid. And then what if we're cutting dough into strips? Is that a change of state or a change of shape? Change of shape. Okay. And again, if you ever have any questions about any of these problems, you can always email me or set up an office hour. And then here are the solutions. So now let's talk about chemical properties and changes. So chemical properties describe the ability of a substance to change into a new substance. So, ability of a substance to change into a new substance. So now we're changing the identity of the substance. So for instance, if you have let's say some iron nails that have been sitting out in your garage or maybe in a tool shed somewhere, over time they're going to react with moisture and oxygen in the air to produce rust. So iron plus oxygen will give us rust. So that's an example of a chemical property because iron has the ability to react with oxygen and become a new substance, which is rust. And this is also an example of a chemical change. So when a chemical change takes place, the original substance is turned into one or more new substances with new chemical and physical properties. So for instance, iron is shiny, it's typically gray, it's metallic, but then rust is kind of a reddish orange color or maybe a brown. It's dull, it's kind of brittle. So iron and rust have completely different properties. So again, during a chemical change, a new substance forms that has a new composition, new chemical properties, and new physical properties. So another example is if you're more of a cook or a baker, sugar caramelizing at a high temperature is an example of a chemical change. So sugar is going from a solid into kind of a sticky, liquidy substance, right? So that's another example of a chemical change. So let's classify each of the following properties as physical or chemical. And if you want to try this on your own first, you can pause the video and then when you restart it, we'll go over it together. Okay, so A, ice melts in the sun. So is that physical or chemical? And remember, if you have a chemical change or a chemical property, that involves a change in identity. So if ice melts in the sun, is its identity changing? No, it's still water, it's just in a different form, right? So that would be a physical property. What about paper can burn? Is the identity of the paper changing? Yes. So if we burn paper, it's becoming soot or ash. So it is changing its identity. So that would be a chemical property. So paper has the ability to burn. What about C? A silver knife can tarnish. And if you're not sure what tarnish is, sometimes silverware will kind of turn this grayish color over time and you have to kind of polish it. I don't think any of my silverware is nice enough to do that, but might not be pure silver. So if a silver knife turns kind of a grayish color, it gets like a grayish coat on it, is that a physical or chemical property? So that's a chemical property because the silver is actually reacting with air to turn into a slightly different chemical. So this is similar to iron rusting. What about D? A magnet removes iron particles from a mixture. Is that physical or chemical? Or another way of asking this is, if we're separating iron from a mixture, are we changing the identity of iron? No, we're just taking it out of the mixture. So this would be a physical property. Okay. Let's do one more. we're going to classify each of the following changes as physical or chemical. So very similar to the last problem. So we'll do this one together. So in A, let's say we're burning a candle and producing smoke. Is that a physical change or a chemical change? So that is chemical because we're producing a new substance, which is smoke. B, ice melting on the street. Is that physical or chemical? Physical. Oh, whoa, I zoomed in. What about toasting a marshmallow? Is that physical or chemical? So this is chemical. And this is similar to caramelizing sugar, right? Marshmallows have a lot of sugar in them. So when you toast them, they kind of can caramelize or burn a little bit. What about cutting a pizza? Is that physical or chemical? So for instance, are we changing the identity of the pizza? Is it becoming a new substance? Nope. So it's physical. We're just changing the shape of the pizza. What about iron rusting in an old car? That's chemical, right? We already went over rust. Okay. So next time, we're going to talk about energy associated with matter. And we'll start with something called specific heat, which is a physical property of different substances. And hopefully this helped you learn how to categorize matter around you into different categories. So whether that's a pure substance, a mixture, or even a physical property, a chemical property, a state of matter, etc. And I will see you in the next video.